Today's lecture is on cognitive psychology. Now, cognitive psychology is all about how you think. It seems like that's what psychology is supposed to be about. This thing right here, we talked about psyche, but cognitive psychology involves your thought processes and all these different things. So there's a whole area devoted to it. I'm barely going to scratch the surface today. Now, I like to think of it as these different patterns that your brain gets into, tendencies that we do. And I'm going to talk about 6 different kinds of tendencies. But when I talk about tendencies or patterns, I like to think about video games because sometimes you get into a pattern and it blocks you from the solution, especially on good games. Okay. When I talk about patterns, I'm going to talk about looping, and later on, I wish I wrote a book on looping. I wrote my book on Gethsemane. I want to write one on looping because I loop, and it's like no matter how much medicine or whatever else I take, I just tend to go over and over and over something in my mind. Now, in this pattern example, you got to break the loop, and to break the loop is to level up. Okay, so I want to use this video game analogy all throughout. Okay, so I forgot I had this on here. It's hard for me to read this. Whatever you hold in your mind will tend to occur in your life. If you continue to believe as you've always believed, well, you're going to act as you've always acted. And if you act as you've always acted, you're going to get what you've always gotten. And then if you want different results, all you have to do is change the way you think. This is the secret to life, but it's hard to do. Okay, so I don't want to go Don Miguel Ruiz right now, but also Joel Osteen, all these other people talk about this, This is like the law of attraction, but if you were in my religion class, I would go on. Okay, so today's lecture, though, is 6 different kinds of patterns. One is going to be called a heuristic. It's a shortcut or rule of thumb. In my other class, I talk about several heuristics. Okay, so just keep in mind, rule of thumb, you kind of estimate something, right? And biases are just tendencies to process things in inaccurate ways. Tendencies to process information inaccurately is what that says. Okay, and so you don't want your referee to be biased, right? He should be unbiased. This is one of my problems with the NBA, that stars get preferential treatment. A foul is a foul, no matter what. And also at the last of the game, it should just be a foul no matter what. But it's biased because, they want, certain production value within the game. Okay, the first one is called the representativeness heuristic. I said it right. I hate this word, it's so long. Basically, it's the stereotype heuristic, and I told you heuristic means shortcut. So stereotype shortcut, well, we do it all the time. I mean, this is why I'm a psychologist. I grew up in the deep south, you know what I mean? There was a train track, and black people live on one side and white people on the other side. And so I wanted to study this, and in my social psychology class, I talk a lot about prejudice and discrimination. Okay, so Kahneman and Tversky were these famous mathematicians, and what they would do is flip a coin. And they told their audience I had 3 different outcomes. The first 6 times I flipped it, I got heads, tails, heads, tails, tails, heads. The second 6 times I flipped it, you see 3 heads in a row, then 3 tails, and the third 6 times I flipped it, I got 6 heads in a row. Now they ask the audience, their participants, which is most likely? Well, most people will say this one because it's most representative of a random event. But what's the probability of a heads or a tail? Everybody knows it's 50-50. It's 50-50 right here, all the way down the line. It doesn't change right here to be only like 5% and 95% tails or something. And if you really think about it and carry the math up to here, all 3 events are equally likely, although people will use their stereotype of randomness and pick this one as more likely than these 2. Sometimes this is also known off of this is the gambler's fallacy, that people ignore facts and numbers and they go with their stereotype. I argue this is what people do in election all the time. It's like either that lady's a bitch or he's a dick. You know what I mean? They're not really doing a careful analysis of what they stand for. And so the gambler in the casino, if it's landed on red 25 times in a row, he's like, oh, blood everything on black. You got a 50% chance of losing still, independence of outcomes. Okay, I hope that one kind of made sense. The second one is called the illusory correlation, and illusory is in the title. Remember correlation? That's like how X and Y are related, like how much you study and what your test grade is. Well, if I throw illusory in front of it, it means the relationship is false. It appears to be a relationship, but it's not. Remember ice cream and drowning? Ice cream doesn't cause drowning. So it means basically false. Now, my example is this. Let's say I'm walking down the street and a black cat walks by, and then immediately I trip and fall. It's like, oh my God, that cat caused me to fall. It's like, no, the two things co-occurred. X and Y co-occurred at the same point in time, and it might be tempting to say X causes Y, ice cream causes drowning, but no, it's just guilty by association. Speaking of which, remember my example about screwdrivers? It's like if you get really sick from drinking screwdrivers, then you won't like orange juice, but orange juice was just a random mixer. It was just there at the scene of the crime. It was guilty by association, but it's not the culprit. Okay, this is all about superstition and how superstition gets started, because two things co-occurred, and then you think X caused Y. And about the most superstitious people in the world, they're called baseball players. They're so superstitious. Think about those necklaces they wear, their hats, the rally caps, all the different stuff, the sunflower seeds, the shit that they chew, whatever. Now, they also are into lucky numbers. If I have this number, it makes me play better because I had that number and I played good. The two things co-occurred. Now, my last example is Michael Jordan. Michael Jordan, I think of as the GOAT, the greatest of all time, but that's not because I like him. It's because he won 6 in a row. Nobody could beat him in the championship games. Like, damn it. And I didn't know this, but later on I found out that he would wear his North Carolina Tar Heel shorts from college underneath his Chicago Bulls shorts for every game of his career as a pro because he felt like those shorts made him play better. That's the illusory correlation. I mean, maybe it did, but I don't know. You be the judge of that. The third one is called contrast effects. This kind of relates to our discussion of optical illusions. You perceive a thing, a stimulus differently based on its surroundings. Well, look at this purple right over here. I mean, that magenta pops against that chartreuse. It don't look so good over here. It looks dull, but it's the same color, purple. Okay, so contrast effects. We think we see things the same everywhere, but we don't. Right? I argue people are like this. If we mistake this B13 and we see it differently based on its surroundings, we'll see people differently based on their surroundings. So the contrast effect is very simple. I have one example, but it's an old example. It's Steve Nash. I miss Steve Nash. I used to go to the games back in the day when he was there, and Amari and like the Matrix and all these people. It was great. But I used to always think, oh, Steve Nash is the point guard. He's a little bitty guy. But the first time I was fortunate enough to get close to him, it's like I was looking up. It's like, oh my God. But Steve Nash is like 6'2" or 6'3". It's like, why do I think he's a little guy, B13? When you're around Yao Ming right here, who is 7 feet 6 inches tall, everybody looks like a little guy, right? So if you're around trees all the time, you're going to appear like a small guy. And that's why I love that B and 13 optical illusion. I hope that one made sense. The fourth one is also real easy. It's called primacy effects. I don't know if you remember from memory, but we weight information. Hopefully I spelled this right. I receive first most heavily, or I remember that information better. And so remember when I had this list of table, cloud, book, tree, so on and so forth, you might have remembered the first of the list better than the last of the list. That was something we talked about with short-term memory. Now, Ash in 1946 did the only study I'm going to talk about, but it is a really famous study because it's about impression formation. So he would give people a list of words that describe Bob. Bob is these things, these 6 things. Now, on day 1, he would like position the list like this, but on day 2, would make the list a little different. Okay, if you look at the difference between lists, it's not real different. List 1 and list 2, actually, it's not different at all. They're just ordered differently. But he would find something interesting. What would he find? On day one, the people would say that Bob is warm and friendly. And on day two, they would say he's cold and unfriendly person. It's the same exact ingredients that are making up Bob, and if you were unbiased, it doesn't matter what order I put them in. But here on day one, I've kind of put the good ones up here at the top. They call this a halo effect sometimes. But I call it the devil effect. Over here, you earn your devil horns up here. And no matter how many good things you do, you can never outlive it. I've done this too many times where I've shown my ass. It's like, dang it, I've done 1,000 good things since that one bad thing I did, and I can't outlive it. Whereas when you do really good at first, people weight that more heavily. And if you do something bad later on, they go, oh, well, he's a good guy. I'm going to give him the benefit of the doubt. Okay, that's everything for the first four. Okay, number 5 and 6 have to do with problem solving, but before I get there, I want to take a little bit of a tangent because it's one of my pet areas. I studied group creativity and problem solving when I was getting my PhD, but another area that I'm really fascinated with is how animals solve problems. And so animals display these moments of insight, these aha moments, just like people. Like they would put this chimpanzee in a room with these bananas suspended from the ceiling right here. And you would think, oh, okay, I just get stuck, kind of like I talked about before, get stuck in a pattern. I try to jump, do whatever. But no, he likes just like a human has his aha moment and levels right up and gets those bananas. He's able to level up and use, things as a tool. So in the next 4 videos, what I'm going to show you are animals using tools or having these aha moments. And then I'll come back and we'll do number 5 and 6. Okay, you see this bird right here. There's a piece of bread right there. I mean, birds eat bread. Why don't you just grab that bread and go over there and have some breakfast? Now he's going to use the bread. He has to be thinking. He's carefully placing it out there. It's almost gone now. The fish have almost all eaten it up. So he would have been better off maybe just eating the bread. Wait until you see the fish he gets. Bam! So awesome. Okay, so that's the first one. And the second one, these are ravens. I'm big on ravens, and they like to eat walnuts. These are in Japan. And so they try to fly real high and throw walnuts on the ground, but walnuts are like a golf ball. When that shit hits the ground, it just bounces. You can barely see it. The resolution is better on this video, but not great. So sometimes that works. That would be tool use, throwing them on the ground, not just trying to crack it with your beak. But what they found in Japan, that these ravens have gotten a little smarter, because ravens are really smart, and they'll stand over the road and wait for cars to drive by and throw them down there, and maybe a car will run over it because they're real hard. See, he's trying to aim for a car. This is great. And if a car runs over it, it's bomb, dude. It's like he's gonna like crush it. See, one of these cars is gonna hit it, and he's gonna like try to get down in there without getting killed. Bam! There's his stuff, his treat. Only problem is a lot of the ravens started getting killed. So some of the ravens got smart. See, he's like not doing a good job. They only position themselves on wires right up here. Oops, I didn't draw good. It went by too fast. Right above these white stripedy things called crosswalks. And so they found that that's a magic place somehow. But they don't just fly right down there. No, they wait. All this is a CS, right? The green ding. And it's also operant conditioning. Now I'm going to go do my work. I'm going to go get my nut. And then that's not all. Once it dings back, he knows to go back out. Ding, I better get out of the street. And so this is amazing. You tell me that animals don't think. Okay, another one about crows. This one, there's a piece of food right down in here. Can't really see it. It's hard to draw on videos. It's right down in the bottom. He's got a piece of wire, so he's using a tool. Now you tell me if this crow is smart or not. Watch what he does. He jams that piece of wire down in there because it hasn't been working, and he twists around and he makes a little hook on the end of it. It wasn't working at first. He had a level up moment, make a hook. I'm gonna hook that shit out of there. Booyah. Okay, so the last one is, you can tell he's practiced it, but this is totally a video game. There's a little peanut right down here in a long tube. You can't really see so good, but the tube goes way down here. Now I can draw on this one because it's static. Now the little stick wouldn't reach that far down the tube, and so he gets the little stick to get the medium stick. But then he goes, the medium stick's not going to reach way down there, so the little stick gets the medium, and the medium gets the big. Tell me that's not a video game. And then the big one is the one that gets my peanut. He almost has it. He's like, not quite. Come on, dude. It's still in there. You didn't do all the work. And there he goes. I hope y'all enjoyed those videos on animals using tools. Number 5 is called mental sets, and it definitely relates to problem solving because we get stuck trying to solve the problem the same old way. Why? Because it worked in the past. And this is why I relate it to video games. It's like, I'm just going to do it the way I did it last time. Well, newer video games will tear you up if you do it that way. And so they are depending upon your rigid thinking. So you have to solve problems in new and creative ways. I don't know if you play Lower Crop Tomb Raider, Call of Duty, or whatever, Battlefield 5 or Sniper Elite. In these kind of games, you have to think a lot. Okay, so the problem I have, I don't know how it's going to work because I usually give this out in class. What you're supposed to do is connect these 9 dots using 4 straight lines, but you're not supposed to lift your pen when you do it. Now, normally I do it this way. I go straight down here, and then I go up. That's 1, 2, and then I'm on 3. So I think I'm doing really good. I'm almost home. And then I go to number 4 right here, and I go, dang it, I missed 1 dot every single time. Okay, a lot of people struggle with this. You can try it at home on your own if you don't want to go to the next slide. Now, here's the problem, is that when you go down here, I was doing the right thing. But I was stuck based on my prior experience because when I got up to here, it's like, wait a minute, you can't go outside of the lines. Well, that was never given in the instructions if I would have handed it out, is that you have to go out of bounds to solve the problem. But my rigid experience ever since I was a little kid is stay inside the yard, stay in bounds, color inside the lines. It's almost subconscious, rigid thinking. Okay. The second one I usually give in class is this. I need exactly 4 gallons of water. But I give you a water hose, and one of these jugs holds exactly 5 gallons and one exactly 3. Now, I spent a lot of time doing this, so we'll see how it works out. Here's the solution to the problem, because a lot of people just try to estimate and say, okay, well, I'll just estimate it based on one of these lines. Okay, but it's not, it's supposed to be exact. So what I do is fill up the 5-gallon bucket completely, or jug, I should say. Okay, so now what do I do with it? Well, I throw it into the 3-gallon jug, but that leaves me with 2 gallons left over. I hope you just follow my logic. 3 plus 2 equals 5, right? Now, what do I do? Well, I can always get 3 gallons of water, perfectly 3 gallons, so I'm going to throw that out. Now I'm going to take this 2 gallons of water and just store it over here for a minute. Are y'all with me so far? I can get it to work. Okay. And then I'm going to try to fill this one up again. So I'll fill this 5-gallon up and I'm going to try to pour it into here. And as I try to pour it into here, only 1 gallon will fit, leaving me with exactly 4 gallons. I hope I didn't just confuse you because it's kind of confusing, but you can always rewatch it again. But it's these kind of problems where you have to like do mental gymnastics with your brain. That's why I really like them. Okay, the last one I think I have are these like chain links, and you're supposed to open and close 3 of these links. You can break these apart, you can't really see, and then you could like connect it to this one. So if you do 3, open and close 3, you can make the whole thing into a circle or a bracelet. Okay, so let me erase all that. I looked at it and looked at it and looked at it. What I'll do is I'll connect these two, I'll connect these two, and I'll connect these two, and I'm still like going like the 9-dot problems. Like one of them is not there. How do I make it? And so here's the solution to the problem. If I just take one and break it apart into 3, it's like, oh, but I didn't think you could break apart the middle one. It's like, why not break apart the middle one? Because as soon as you break apart the middle one, you have the solution to the problem because now this goes here, and this goes here, and you connected the whole thing. Number 6 is called functional fixedness. So functional fixedness is basically mental sets with an object. Well, what does that mean? Well, let's take a hammer, for instance. If you ask a little kid what you can do with it, they don't tend to be functionally fixed. I did brainstorming research, so we're always trying to do the opposite of functional fixedness. They might say, oh, yeah, you hammer nails, but also you could use it as a crowbar, a door holder. You could also maybe like as a paperweight, all these different ideas they might come up with. And so that's creativity. So the opposite of that is not creativity. It's like, no, you can only hammer nails with it. So one of the only problems I'll show, I could show a bunch of things right here, is the candle problem. Dunker in the 1930s started doing this. He said to people, I'm going to give you these objects right here, and I want you to attach the candle to the wall and light it for me. Okay, so people tried all kinds of things. They tried to melt the wax, they tried to tie the string around the candle and attach it with the thumbtacks, and they would spend a lot of time doing it. And he goes, you couldn't solve it in 1 second, like 1 second. All you do is dump the matches out and then just do this. It's like, but people go, oh no, that box is just for holding matches, functional fixedness. It's not for other purposes. And so this is the example of functional fixedness that most psychologists use. I think video games are a better example because if you get functionally fixed on a video game, you won't get through the level. Okay, those 6 things should be really easy. You don't have to remember this part for the test, but in a way, this relates to all of your tests, and this is my wrap up for memory and cognition. How do you eat an elephant? The answer is 1 bite at a time. So when it comes to information, don't try to take it all in at the same time. Reminds me of when I was getting my PhD. At the end of your 2nd year, you have to do something called qualifying exams. What does that mean? Well, in May, they give you all these like books and research articles and journals, and they say, Tim, I want you to read every single one of them. It's like, I hate reading. It's like, damn, how am I going to do that? Because at the end of the summer, you come in for the exam, which is 8 hours long, and it's an all essay test, and they can ask you anything they want to, and if you fail it, you're out of school. You're done. You're not going to get a PhD. It's like, dang, talk about stress. So when I looked at it, it seemed insurmountable. But then I remembered tame dogs and wild cats. And so I started to break it into baby piles. Like this pile could be about helping behavior. Or this pile might be all articles on prejudice and discrimination. Or this pile is all articles about attraction. Now, if there was only 6 articles about attraction, when I got onto the test, it's like, oh yeah, there was those 2 books and those 4 articles. Yes, I'm going to do it. I'm going to kill it. So that helped me out tremendously, because as you go through school, the elephants get bigger and bigger. Okay, so the other thing, the last thing about your notes, some people's notes are like one big run-on sentence. And it's like you need to break them into piles, at least separate with a little white space right here, 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 here. And so if you separate with this white space, then what happens is like you have the 7 parts of the neuron, or you have the 7 parts of the brain, or you might have like the endocrine system, so on and so forth. Okay, so one last thing, a lot of people like to use note cards when they try to remember things. But my beef against them is you usually put one piece of information on each note card, which essentially recreates the elephant. You have one big fucking pile again. So I say use color. This is my inappropriate analogy. Gay that shit up. Okay, so if you're going to take the elephant apart and you're going to break him into like little piles, let's say I made these piles. I know I could have made another one right here for maybe social learning, but let's just say I have classical and operant, 2 different piles. And then 2 different piles over here for memory and cognition. I made it simplistic. So now I can remember 3 or 4 note cards that have to do with CS, UCSC, or UC. You see what I'm talking about. The only problem is if I'm walking across campus and I go, whoops, and I drop them all, then they all jumble up and I recreate the elephant. And that's the bad part of it. So what I say then is to gay that shit up. And then if you use color, you can, even if you drop them on campus, for instance, all the green ones are about operant conditioning, and I know 3 or 4 green cards for the test. Okay, last thing. This is from a student that I love to death, and this is how she did her notes all the time. Me and her would talk about it because we're both the same. It's like, oh yeah, purple is dendrites, and red is action, axon. That's where the electricity is. And the blue down here, oh yeah, the blue is the where the neurotransmitters get released out of the buttons. Oh yeah, and green is a protector. Now, sometimes you can overdo it. You can see how I get to overdoing it all the time. But hopefully that helps you out. Okay, I'll see you next time.